A and B and C are integers, and A squared minus B squared equal to 24. B squared minus C squared equal to 16. Find the value of A, B, and C. So, for solving this at first, I can say A and B and C, because I have only square. I can say without lots of generality, A, B, and C are at least 0, because if one of them negative, and at the end of the problem, for example, if I find A2, I know plus minus 2 works, because I have only A squared, sign is not important. So I solve for non-negative numbers, and at the end, I also consider negative cases. Okay, so let's focus on these two variables, these two equations. From first one, I can say, because 24 is positive, so A squared minus B squared is positive. So I can add plus B squared to both sides, so A squared is greater than B squared. So because A and B are at least 0, I can say A is greater than, strictly greater than B. Similarly here, I can say it is positive, so again B squared minus C squared is positive. So again, by the same way, we conclude B is greater than C. So if we combine these two things, A greater than B, greater than C, C greater than equals 0, because of these parts. So let me rewrite it, the equations. I have A squared minus B squared equal to 24. I have B squared minus C squared equal to 16. And then let's see, working with which of them is better. I can say for this one. I know that we have a famous identity that B squared minus C squared is B minus C times B plus C. And because we know C is at least 0, so we know that it is less than or equal this. Why? Because look, B minus C less than or equal B plus C is equivalent. We can cancel B, subtract B from both sides. This equivalent, and then take this to right hand side like equality. You can do this. 2C greater than equals 0. And we know because C is greater than equals 0, it is okay. So B minus C less than or equal B plus C. The reason, if I want to tell you intuitively, you can say B is same. C is non-negative number, so minus C is less than or equal plus C, and the equality only holds when C equal to 0. So it is equal to 16. And now, we know because B and C are non-negative numbers, and B also is positive, so this part is positive. The product is positive, so this part has to be positive. Now, if I want to write the cases, it can be 1, 16, it can be 2, 8, it can be 4, 4. So I should consider only these 3 cases. But if you consider the first one, you can see it doesn't work. One way you can say the parity of these two numbers are same. If you don't know it is what, let me tell you easily. If you add these two things, B minus C plus B plus C, it will be what? B minus C plus B plus C, because one of them is 1, one of them is 16. It will be 17, 1 plus 6. Negative C cancel will be cancelled. 2B equal to 17. It is even. 17 is odd, so it doesn't work. Let's check second one. Again, if we add B minus C plus B plus C, negative C and C will be cancelled. So 2B equal to 2 plus 8, which is 10. And B equal to 5. So because B is 5 and B minus C is 2, so C will be 3. If you replace, C will be 3. So one answer here, it works. The other one. If you add again this part plus this part, it will be 2B. 4 plus 4 is 8. You divide by 2 is 4. And for example, if you check this, or the first one, B4, B plus C is 4, so C is 0. Now, we've reached 2 answers. That's B5, C3. Let me write B5, C3. And next one, B4, C0. So, because we've checked the second equation, it works. Now we should work on first equation. A squared minus B squared should be 24. A squared minus B squared should be 24. This first case, it is second case. By first case, A squared, B squared is 5 squared, because B is 5 here, equal to 24. A squared minus 25 equal to 24. If we add 25 to both sides, A squared will be 49, and A will be 7. So, found one answer, A7, and as you can see in the first of the video, I said, okay, you consider all of them without loss of generality greater than equals 0, and at the end we consider plus minus because it works. Plus minus 7 for A, plus minus 5 for B, plus minus 3 for C, it is A, it is B, it is C. We have 8 answers for each of them, plus of each of them to minus. All signs are okay. Now, if you check this one, second case, we can say A squared minus B squared is 4 squared, equal to 24. First equation here. Now, A squared minus 16 equal to 24. So if we add 16 to both sides, A squared equal to 40, but it is not perfect square. So our only answer is this, and it will be 8 answers. We can write all of them, or you can say, if you know counting, you say 2 cases times 2 cases times 2 cases, 8. If you don't know counting principles, I write all 8 answers for you. And please don't forget subscribing, turning on notification, and like the video. And if you have other solutions, comment below this video. So 7, 5, 3. Now, I check one of them negative, this one, 7, negative 5, 3, 7, 5, negative 3. Two of them negative, negative 5. This 3, negative 7, 5, negative 3, and 7, negative 5, negative 3, or all of them negative. Negative 7, negative 5, negative 3. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 answers for this problem. Okay, thanks for watching this video. If you have other solutions, comment below this video for having next questions and next solutions, next ideas. Again, as I said before, don't forget to subscribe, turn on notification, and like the video. Thank you.